Okay, so now I'll be showing to you how to use the tools. So we have some functions, we have some sub VIs that you can use for the codes, and then I'll be showing this video how to use them. So first of all, if you go here to your computer and find the library in your memory, you'll be able to see a project with the examples. So Felipe Ferreira, open this guy and open this project. You'll be able to see the project with the example, this project here. Okay, so I have the library itself and I have this folder showing how to use each one of the tools of the library. So for example, if I take here point to point is one of the examples that we have, and basically it works by setting a starting point and an end point, and then once you run, you're able to move from the starting point you set to the end point you want. Okay, and then you can put any position you want, and then the robot will go to where you want. So for example, I can put here, let me change this guy. When I run, my robot goes, calculates, and simulates everything for me. It also shows the full distance that my robot have to travel. And if you go here to the block diagram, you'll be able to see how to use, how to run these tools. So here is the code that the program that calculates the path for going from the start to the end. So when I run this guy here, it will calculate the path, necessary path. When I apply to path driver, it will make my robot go to this position. Okay. Here's only a loop to plot. So whenever you want to plot what you're testing, you can add this loop with these informations here. Okay. This code here, it simulates the robot. Later I'll show how it works. Okay, so each one of these examples give you an explanation in how to use each one of the tools that you have available. So for example, this other one, different from the previous one, is not a point to another point, it's a point to an object. So here I'm going from this point to this object here. So from the point 3700 here in X to my dispensary. I could also put a different object for example, PG1. My robot would go from the initial position to PG1, just like it would go to any other object that you set and also any other position you want. If I check the block diagram, it works similar to the test before, the point to point. But here the only change is that instead of calling the point to point function, point to point to sub VI, I'm calling the point to object. And it works the same, calculates the path, prints, draws the environment, and this guy simulates your robot. I also have test test sensoring. So it simulates the environment, simulates your robot, and it basically gives you the position of a robot regarding the sensor informations. So here I can set a different position for my sensor. You can set different sensors and each sensor will have different position. So for example, here I put 100 in X, better 100 in Y, 150 in X. Okay, so regarding the initial position, the center of your robot, you can define this position here. So for example, if I change here, it will change the position in my robot. Okay, and according to this position, it will determine this guy here. So for example, if I change in X, you see that this guy changes. Okay. So what does this information, what does it represent for us? Okay. So I know that the distance from my sensor to my wall is 150. So it means that from here, this blue element represents my sensor. And then this red line here represents my sensor and the distance that it's measuring. And from my wall to my center, I have 150. From my sensor to the center of my robot in X, I have 200. It means that the real position of my robot is 350. So this code here calculates for you the real position of your robot. So my robot think that's in 500, but using my sensor, I realize that no, since I have 150 and 200, it's 350. Okay. Through the software, I could also change the position and the orientation of my sensor. So, for example, instead of facing forward the front of my robot, I could also face the side. So I could add sensors on the side of my robot, and you can check here that the axle that's being measured also changed. So before, when the sensor is facing the front of my robot, it's measuring X. If I change the orientation, it also changes by itself automatically the axle that's being measured. Okay, so here I could add this sensor. Let's try to put in a more real example. So here, let's say I have a sensor here on the left side of my robot that's measuring my Y. Okay, now, regarding this position, my robot is using this wall as reference to estimate the position of my robot. And that's how the software works. We have here this other guy. So this one is the idea is to create a path of movements. So let's say I want my robot to do these movements here. So 600, 1000, 1100, and then okay, so the idea this guy is you set a path that you want to test, that you want to try, and then the robot will follow this path. You can also change the angles. So let's put some angles here, and then the robot will try to follow them. So if you pay attention, you see that the robot is also rotating, not only moving. And then you can put here any coordinate that you want, and then you can try. So now I put to go around here with an angle of 90, and then my robot goes to this position. Okay, if we check the block diagram, works very similar to the ones that we were using before. The difference is that I don't have a sub VI here calculating the path, since you're already providing this path. So it will only follow this path using the path driver that calculates the speeds that the robot need to follow in order to reach point by point. And I also have, again, the odometer simulating a robot, and this guy to draw your environment. The last test that we have is for testing the circular movement. So the idea here is to provide the coordinates you want your robot to go, and the radius that you want this movement to have. And then the software here will calculate, to estimate, and show to you how would it be this movement. Okay, so here is this for 200 millimeters radius. You can change the radius for make it sharpen, okay, or to make a more open movement, and then it simulates and shows to you. You can have non-rectangular movements, so you can break. Since here the radius is too small, it will make this curve here, but we could put a bigger radius and then it would be smoother. So that's the idea with this software, to test and try different configurations for your circular movement. Here's how it works. Basically, I have this guy here that calculates for me the circular movement, the speed. So regarding the positions, it gives me the speeds that I need, and then I can apply these speeds to my robot. This other part here, this extra part, is for simulating these points and this position that you're seeing here. So during these examples, I was showing, for example, here in odometry, we have this guy here, odometry. What does this VI does? It's basically a code, an example of an odometry system where I apply the kinematics of my robot, where I apply the PID for controlling the speeds, okay? And it would apply to my robot. So here, what happens? It comes a velocity. So this velocity can be from any source. So you can have any code, any sub VI changing the numbers in this velocity. This velocity would be applied to my inverse kinematics. So from global to local. Okay, and here I'm measuring the speed of my robot, my current speed of my robot, and I'm comparing the one I want with the one I have applied to my PID, and my PID determines how much speed that later will be converted into PWM, how much apply to my motor in order to have this speed that I want here. Okay, so here's an example of a simple odometry system with a direct or forward kinematic and my inverse kinematics. This robot simulator is only a simulation, so here I don't have any hardware implemented in my system. So it's only a guy that takes a PWM and converts into a simulation of what would be an encoder. For you, you'd have to change basically this guy and here. So here I would apply the PWM, and then doesn't matter the hardware that you're using. Okay, any hardware would work. You just apply here the PWM to this hardware that you have to your robot, and here you measure the encoders of the wheels or any other sensor that you use for odometry. And then it calculates the speeds that you need and also calculates the position. Okay, so this is the guy that simulates your hardware. In your case, you would have to add in your project here a target or a device. So let's take, for example, anyways, you have to add your hardware. Could be a MyReal, a Raspberry, whatever you want. So you would add your codes, your libraries, and your odometry to any hardware that you might have in your system. So for example, here I have a Raspberry, here we have some other hardwares. You can have a different other hardware. This library is not specific for any hardware. It might work for any hardware that you might want to use. And that's it. That's how to use this library.